Right now, as you're watching this video, there are things happening all around you that science cannot explain. Your consciousness, the placebo effect working in someone's body, dark matter holding galaxies together, gravity bending space and time. We've split the atom. We've mapped the human genome. We've sent robots to Mars. But there are mysteries so profound, so deeply puzzling, that the brightest minds on Earth are still scratching their heads. I'm talking about phenomena that challenge everything we think we know. Questions that have haunted scientists for decades, some for centuries. Today, we're diving into the deepest mysteries that science still can't explain. And trust me, by the end of this video, you'll never look at reality the same way again. This is Gray Chapter. Let's uncover the unknown. Before we start, here's what makes these mysteries so fascinating. These aren't conspiracy theories or pseudoscience. These are legitimate questions that professional scientists are actively trying to solve right now. Each mystery we're covering today has been studied, researched, and documented. Yet despite all our technology and knowledge, we still don't have solid answers. Some of these might keep you up at night. Others will make you question the nature of reality itself. So grab a coffee, get comfortable, and let's explore the edge of human knowledge together. Let's start with something incredibly personal, something you're experiencing right this second. Your consciousness. Think about it. You're aware that you're watching this video. You can feel emotions. You can make decisions. You have thoughts, memories, dreams, and a sense of self. But here asks the mind-bending question. How does a 3-pound lump of meat inside your skull create the rich, subjective experience of being you? Scientists call this the hard problem of consciousness, and it's arguably the biggest mystery in all of science. We know a lot about the brain. We can map which areas light up when you're happy, sad, or making decisions. We understand neurons and synapses. We can even predict some behaviors by watching brain activity. But none of that explains the actual experience of consciousness. Why does processing information in your brain feel like something? Why aren't we just biological robots, responding to stimuli without any inner experience? Here's where it gets even stranger. Scientists can't even agree on what consciousness actually is, let alone how it emerges. Some think consciousness is just a byproduct of complex brain activity, like how traffic jams emerge from many cars. Consciousness emerges from billions of neurons firing. Others believe consciousness might be fundamental to the universe itself, woven into the fabric of reality, like space and time. And here's the really wild part. There's no way to prove that anyone else is conscious. I can't experience your subjective reality. You can't experience mine. We assume other people are conscious because they act like us, but we can't actually prove it. Scientists have tried everything to crack this mystery. Brain scans, studies on coma patients, research on split brain patients, even experiments with psychedelic drugs. But the hard problem remains unsolved. Why do we have this inner world of experience? Science still has no answer. And that leads us to our next mystery, which is just as close to home. Imagine this scenario. You're in terrible pain. A doctor gives you a pill and tells you it will help. Within an hour, you'll feel significantly better. But here's the twist. That pill was just sugar. No active ingredients. No medicine. Just a placebo. Yet you healed anyway. This is the placebo effect. And it's one of the most bizarre phenomena in all of medicine. The placebo effect isn't just about feeling better in your head. We're talking about measurable, physical changes. Real healing. Actual physiological responses. Studies have shown that placebos can reduce pain, lower blood pressure, improve Parkinson's symptoms, heal ulcers, and even help with depression. In some trials, placebo surgeries where doctors just make an incision and sew it back up work, almost as well as the real surgery. Your belief that you're being treated can trigger genuine biological changes in your body. But how? How does a thought, a belief, a mere expectation trigger real physical healing? Scientists have some theories. They know the placebo effect involves the brain releasing natural painkillers called endorphins. They know it activates certain areas of the brain associated with reward and expectations. But that doesn't fully explain it. How does your brain know what changes to make? How does expectation translate into specific biological responses? And here's the really weird part. The placebo effect is getting stronger over time, especially in the United States. Placebo responses in clinical trials are now so strong that many new drugs can't beat them. Drug companies are actually struggling to prove their medications work better than sugar pills. Some researchers think it's because of pharmaceutical advertising. We're so bombarded with messages about miracle drugs that our expectations have skyrocketed, making placebos more effective. There's also a reverse phenomenon called the nocebo effect. If you believe something will harm you, it actually can, even if it's completely harmless. People in trials who think they're getting a drug experience the drug side effects, even when they're only getting sugar pills. Your mind can heal you. Your mind can harm you, and science still doesn't fully understand how or why. It is a reminder that the connection between mind and body is far more mysterious than we ever imagined. Now, let's zoom out from the human body to the entire universe. Here's an embarrassing fact for modern science. We don't know what 95% of the universe is made of. I'm not exaggerating. Everything we can see, every star, every planet, every galaxy, all the atoms that make up you and me, all of that accounts for only about 5% of the universe. The other 95% is completely unknown. We call it dark matter and dark energy, but those are just names for our ignorance. Let me explain how we discovered this cosmic mystery. In the 1930s, a scientist named Fritz Zwicky was studying galaxy clusters. He noticed something odd. Galaxies were moving so fast that they should have flown apart. The gravity from all the visible matter wasn't strong enough to hold them together. It was like watching a spinning merry-go-round, where everyone should fly off, but somehow they stay on. Zwicky proposed there must be invisible matter we can't see. Dark matter. Matter that doesn't emit light or any other radiation, but has mass and gravity. Later, astronomer Vera Rubin found the same problem with individual galaxies. Stars at the edges of galaxies were moving too fast. There had to be more matter than we could see. Today, we estimate that dark matter makes up about 27% of the universe, but we have no idea what it is. It's not regular matter. It doesn't interact with light at all. It passes right through normal matter. We only know it exists because of its gravitational effects. Scientists have proposed dozens of candidates for what dark matter might be. Exotic particles with names like WIMPs and primordial black holes. Modified gravity. But despite decades of sophisticated experiments, we haven't detected dark matter directly. And then there's dark energy, which is even more mysterious. In 1998, scientists discovered that the universe isn't just expanding, it's accelerating. Something is pushing the universe apart, faster and faster, working against gravity. They call this mysterious force dark energy. It makes up about 68% of the universe, but what is it? No one knows. The best guess is that it's energy inherent in space itself. But that creates more problems than it solves. Think about this. Scientists have built billion-dollar detectors, launched space telescopes, and conducted countless experiments. And we still can't figure out what 95% of reality is made of. It's humbling. And it suggests that our understanding of the universe is far more limited than we like to admit. Speaking of things we don't understand, let's talk about gravity. You probably think we understand gravity pretty well. After all, we can predict planetary orbits, send rockets to space, and explain why you don't float off the Earth. But here's the truth. We can describe what gravity does. We just don't know what it is. Isaac Newton gave us the first mathematical description of gravity over 300 years ago. He showed that objects attract each other with a force proportional to their masses. It worked beautifully for predicting how things move. But Newton himself admitted he had no idea what gravity actually was. He called it action at a distance, and it bothered him deeply. Then Einstein came along with general relativity. He showed that gravity isn't really a force at all. It's the curvature of space-time. Massive objects bend space and time around them, and other objects move along those curves. It's like putting a bowling ball on a trampoline. The ball creates a dip, and if you roll a marble nearby, it curves toward the bowling ball. Not because of a mysterious force, but because the surface itself is curved. Einstein's description is more accurate than Newton's. It explains things Newton couldn't, like why Mercury's orbit behaves oddly, or how black holes work. But general relativity still doesn't explain what gravity fundamentally is. Why does mass curve space? What's the mechanism? And here's where it gets really problematic. Gravity doesn't play well with quantum mechanics, the other pillar of modern physics. Quantum mechanics brilliantly explains the other three forces of nature: electromagnetism, the strong nuclear force, and the weak nuclear force. These forces are carried by particles, called bosons. Scientists think gravity should work the same way, carried by particles called but no one has ever detected a graviton. And all attempts to create a quantum theory of gravity have failed. String theory tries to unify gravity with quantum mechanics, but it's incredibly complex and might be impossible to test. Loop quantum gravity is another approach, but it has its own problems. The bottom line is this: despite being the most familiar force in our daily lives, gravity remains deeply mysterious. We still don't know how it works at the quantum level, what carries it, or how to unify it with the rest of physics. It's one of the biggest open questions in science today. Now let's tackle a mystery that's more personal. Where did life come from? We know life exists. We're proof of that. But we have no idea how non-living chemistry became living biology. Think about the gap we're trying to explain. On one side, you have simple molecules: water, methane, ammonia, basic amino acids. On the other side, you have a living cell with DNA, proteins, membranes, metabolism, and reproduction. That's an enormous leap. Scientists have been trying to recreate the origin of life in laboratories for over 70 years. The famous Milori experiment in 1953 showed that amino acids, the building blocks of proteins, could form naturally from simple chemicals. That was exciting. But amino acids are a long way from life. You need those amino acids to link together into proteins. You need DNA or RNA to store information. You need a membrane to create a boundary between the cell and its environment. You need metabolism to harvest energy. You need reproduction so the cell can make copies of itself. And somehow, all of these components need to come together at the same time and place. It's like throwing car parts into a junkyard and expecting them to assemble into a working vehicle. Here's the chicken and egg problem that really stumps scientists. DNA stores the instructions for making proteins. But you need proteins to read DNA and copy it. So which came first? Some scientists think RNA came first, since it can both store information and catalyze chemical reactions. But even creating RNA naturally is incredibly difficult. Others think metabolism came first, with simple chemical cycles that gradually became more complex. But without information storage, how would that complexity be preserved? Still others think life began in deep-sea hydrothermal vents, where hot mineral-rich water provides energy, or in clay deposits, or in space, arriving on meteorites. We have dozens of hypotheses, lots of experiments, but no clear answer. And here's what makes it even more challenging. Life on Earth started very quickly. The Earth is about 4.5 billion years old. For the first few 100 million years, it was a molten hellscape. But we have evidence of life dating back 3.8 billion years, maybe even earlier. That means life emerged almost as soon as conditions allowed. Was it incredibly easy? Or incredibly lucky? We don't know. And until we either create life from scratch in a lab or find life on another planet, we won't know how special or common our existence really is. It's one of the deepest questions in all of science. How did dead matter become alive? Here's a mystery about something you'll do tonight. Sleep. You'll spend about a third of your life unconscious, lying still, vulnerable to predators, not hunting or gathering food or reproducing. From an evolutionary standpoint, sleep seems like a terrible idea. Any ancestor who slept less should have had a massive advantage. They could spend more time finding food, watching for danger, and taking care of offspring. Yet every animal with a brain sleeps. Mammals sleep. Birds sleep. Reptiles sleep. Even insects and worms sleep. So, sleep must be incredibly important. But here's the mystery. We don't really know why. We know sleep is essential. Deprive any animal of sleep long enough, and they'll die. Humans who go without sleep become confused, paranoid, and eventually start hallucinating. Chronic sleep deprivation increases the risk of heart disease, diabetes, obesity, and early death. Clearly, sleep is vital. But what is it actually doing? Scientists have discovered that a lot happens during sleep. Your brain consolidates memories, moving them from short-term to long-term storage. It clears out toxic waste products that build up during the day. It strengthens important neural connections and prunes away weaker ones. Your body repairs tissue, releases growth hormones, and regulates metabolism. But here's the question. Why does all of this require unconsciousness? Why can't the brain do maintenance while you're awake? Some scientists think the brain is so active during waking hours that it can only do deep maintenance when external stimuli are reduced. It's like trying to repair a highway. You need to shut down traffic first. Others think sleep serves some fundamental function in how neurons work, something so important that every animal with a nervous system must do it. Dreams are an even bigger mystery. Why do we experience these bizarre, surreal narratives while we sleep? Freud thought dreams revealed unconscious desires, but modern neuroscience doesn't support that. Some think dreams are just random brain activity, meaningless static. Others believe dreams help us process emotions or rehearse responses to threats. The truth is, we're not sure. What we do know is that sleep is universal, essential, and uses a huge amount of your life, and we still can't fully explain why you need to do it. It's a reminder that even the most ordinary parts of life can hide extraordinary mysteries. Let's end with perhaps the most profound mystery of all. Why does the universe seem perfectly designed for life? Here's what I mean. The laws of physics depend on certain fundamental constants: the strength of gravity, the charge of an electron, the mass of a proton, things like that. And here's the weird part. If any of these constants were even slightly different, life couldn't exist. If gravity were a bit stronger, stars would burn out too quickly for life to evolve. A bit weaker, and stars couldn't form at all. If the strong nuclear force were slightly different, atoms couldn't exist. If the cosmological constant were different, the universe would have either collapsed immediately or expanded too fast for galaxies to form. Scientists have identified dozens of these constants, and they all seem to be set to just the right values to allow for a universe with stars, planets, chemistry, and eventually, life. It's like someone carefully tuned a giant cosmic radio to exactly the right frequency. This is called the fine-tuning problem, and it's one of the most debated topics in physics and philosophy. There are basically 3 explanations, and all of them are mind-blowing. First, maybe it's just coincidence. We happen to get incredibly lucky, and the constants just happen to be right. But the odds of this are so astronomically small that most scientists find it hard to accept. Second, maybe there's some deeper law of physics we haven't discovered yet that explains why the constants have to be these values. This would be elegant, but no one has found such a law. Third, the multiverse theory. Maybe there are countless other universes, each with different physical constants. Most of them are dead, lifeless voids. But by sheer probability, some universes like ours have the right constants for life. We exist in one of these rare universes simply because we couldn't exist anywhere else. It's called the anthropic principle. We observe a life-friendly universe because if it weren't life-friendly, we wouldn't be here to observe it. The multiverse idea is attractive to many physicists because it avoids having to explain the unlikely coincidence. But it has a big problem. If there are infinite universes that we can never observe or interact with, is it even science? Or is it philosophy? Some scientists and philosophers go further. They suggest that the fine-tuning implies a designer, some form of intelligence that set the constants deliberately. But this raises more questions than it answers. Who designed the designer? The truth is, we don't know why the universe is the way it is. We don't know if there's a deeper explanation for the constants of nature. We don't know if we live in one of many universes or the only one. It's a mystery that sits at the intersection of science, philosophy, and maybe even spirituality. And it reminds us that despite all our progress, there are still fundamental questions about existence that we cannot answer. So there you have it. 7 profound mysteries that science still can't explain. Your consciousness, The thing that makes you you remains unexplained. The placebo effect shows us that belief can trigger real healing, but we don't know how. 95% of the universe is made of dark matter and dark energy that we can't detect or understand. Gravity, the most familiar force, doesn't fit with our understanding of quantum mechanics. We don't know how life began from non-living chemistry. We spend a third of our lives sleeping, but we're not sure why we need to. And the universe appears fine-tuned for life, but we don't know if that's coincidence, necessity, or something else entirely. These mysteries are humbling. They remind us that for all our technological achievements, we still have so much to learn. But that's also exciting. These unsolved problems represent the future of science. Somewhere out there, maybe even watching this video right now, are the people who will crack these mysteries. The next Einstein, the next Darwin, the next great mind who will push human knowledge forward. Science isn't about having all the answers. It's about asking better questions and being honest about what we don't know. If these mysteries fascinated you as much as they fascinate me, you're in the right place. Here at Grey Chapter, we explore the edge of human knowledge, the questions that keep scientists up at night, the phenomena that challenge our understanding of reality. If you want more content like this, hit that subscribe button and turn on notifications. We release videos every week, diving deep into the mysteries of science, history, and the human mind. Drop a comment below and tell me, which of these mysteries do you think will be solved first? Or is there another unsolved mystery you'd like us to cover? And if you really enjoyed this video, share it with someone who loves science and deep questions. Let's grow this community of curious minds together. Remember, the universe is strange. Reality is mysterious, and there's always more to discover. This is Grey. Stay curious, and I'll see you in the next video.